Hello students, so today I will tell you the protecting groups for the alcohols. Okay, so in my previous lecture I gave you about the introduction of protecting groups. So what are protecting groups? Protecting groups are any group which protects or blocks the more reactive functional group temporarily, so that we may react the less reactive functional group, so that we can get the desired product. Okay, so the protecting groups of alcohol, it may be of two types. I will discuss the two type of protecting groups for alcohol. One is as a ether, so ether as a protecting group of alcohol, and or the esters as a protecting group of alcohol. Okay, so today I will tell you about the ethers as a protecting group of alcohol, and this is the part 1. Now, so let's summarize the various ethers as a protecting groups for alcohol. Then I will tell you about their details. So one of the for like protecting groups. First, this protecting groups, let me make a table. Okay, and then reagents used, after that T-protecting agents, okay. So let's first give you the brief about the various ethers as a protecting group for alcohol. Now, first, benzyl ether. Okay, so I may write this formula. Okay, so this is the benzyl group. Okay, this is benzyl ether. Suppose we have ROH, then ROH that may react with a suitable reagent to give you the benzyl ether. So benzyl ether, for the reagent use, the reagent that we use, that is we may use the benzyl chloride. We may use benzyl chloride or bromide. Okay, so let me write benzyl chloride. So for deprotecting this benzyl ether, we do usually hydrogenolysis. Hydrogenolysis, that is palladium in presence of or hydrogenolysis palladium charcoal. Now, second one that I will tell you, tertiary butyl ether. Tertiary butyl ether. Okay, so the formula, okay, tertiary butyl ether, and for this we may use the isobutylene in presence of, suppose I use H2SO4. Okay, so isobutylene, and this is used under anhydrous condition. Isobutylene under acidic condition. Okay, so this may be deprotected in presence of this acidic hydrolysis can be done to deprotect it. Third important one is tetrahydropyrenyl ether. tetrahydropyrenyl ether. It may be written as THP. Usually we denote it by THP. And this is your tetrahydro and tetrahydropyron and tetrahydropyrenyl ether. So if we have ROH, then it will react with this tetrahydropyrenyl ether, tetrahydropyrenyl to give you the tetrahydropyrenyl ether. So for this, the reagent used is, we can use dihydropyron. Dihydropyron is in presence of in acidic condition. And to deprotect it, we may do the acidic hydrolysis. Again, we may do the acidic hydrolysis. Okay. Now, fourth important one is trialkyl silyl ether. Trialkyl silyl ether. Okay. So, trialkyl silyl ether, we may represent it by suppose this is R1, R2, R3. So R1, R2, R3, it may be different alkyl group may be present over here. And so for this, we can use a trialkyl silyl chloride as a reagent. Trialkyl silyl chloride. Okay. And for this deprotecting agent, we use a particular deprotecting agent, and it is named as TBAF. Okay, so TBAF is a protecting agent. So we may write it, that is tetra butyl amino fluoride. Okay, so the structure, if we may write the structure, so this is tetrahydroamine, and this positive charge over here, and this is fluoride ion. Okay. So we may have different types of trialkyl silyl ether. So if we see different trialkyl silyl ether, then let me give you the different formulas for this trialkyl silyl ethers. So it may be, suppose this is one of the, if you may write methyl group. If all this this R1, R2, R3 are the methyl, then this is trimethyl silyl ether. You may write it trimethyl silyl ether. Okay, it is TMS, trimethyl silyl ether. In the same way, if ethyl group is present, suppose if ethyl group is present, then we may write it, trimethyl ethyl silyl ether. Triethyl silyl ether. Okay, triethyl silyl ether, TES. In the same way, suppose if we have isopropyl group, we may have isopropyl group. So if isopropyl group is present, then it is triisopropyl ether. Okay, triisopropyl silyl ether, TIPS, TMS, TES, TIPS, and then another one we may have so two methyl groups are present and one tertiary butyl group is present. So it is tertiary butyl dimethyl silyl ether. Okay, it is tertiary butyl dimethyl silyl ether. So we may write it as a tertiary butyl dimethyl silyl ether. Okay, so it is triisopropyl silyl ether. It is triisopropyl silyl ether. And next one is so here one group is tertiary butyl, another two groups are the phenyl. So it may be written as tertiary butyl diphenyl silyl ether. So it may be written as tertiary butyl dimethyl silyl ether, and it is T tertiary butyl TB diphenyl TPS TB DPS. Okay, so TMS, TES, TIPS, TB, DMS, TB, DPS. So these are the different forms of trialkyl silyl ether. And if we see the stability, then it has the bulkiest group over the silicon. So that's why this is most stable. This is most stable. If we see the stability, then this is most stable, and this is having the least bulkier group. That's why this is the least stable. So this is a stability order. So we have benzyl ether. So benzyl ether, we may write it sometimes. We can write it as a ROBN. This is BN means benzyl ether, ROBN. Or sometimes we may write it as a ROPH. Phenyl. This is benzyl group. This may either. Anyway, we can write it. So benzyl ether, tertiary butyl ether, tetrahydropyrenyl ether, trialkyl silyl ether, and these are the various reagents used to protect this alcohol, and this is the various T-protecting agent for this. Okay, now let's see this one by one. Let's see the benzyl ether. First, I will discuss the benzyl ether. Let's see the benzyl ether. Benzyl ether. Okay, so we may write it as a ROBN. And deprotecting agent used is the hydrogen palladium charcoal, and the hydrogenolysis of this bond will takes place. So this is benzyl ether, and the reagent used to get this benzyl ether, that will be the benzyl chloride, benzyl bromide may be used. So let's see one of the example. So let's see the example. So suppose if we have in a general way, if I write in a general way, suppose this is ROH. So this in presence of benzyl chloride, in presence of benzyl chloride, So this will form a ether. So this may occur in presence of either sodium hydride. If we write sodium hydride may be used to extract this acidic hydrogen from here, and what we may get so this one like this. And so this is the protection, and further the deprotection can be done. So for deprotection, hydrogen palladium charcoal hydrogenalysis of this bond will takes place. So H, one of the H will come over here and the H here. So ROH, we will get again ROH, and we have the okay. Now let's see one of the example. So if I write one of the example, so if we have suppose this conversion, if we have suppose this is the conversion, and we have to convert it into this. First let's see the conversion. Okay, so we have two OH group. So first of all I will protect one of the OH group, so with the help of this benzyl chloride. So we may use suppose sodium hydride to extract this hydrogen, acidic hydrogen, then we may use the benzyl chloride. Okay, we may use the benzyl chloride. Now after this extraction, okay, so this will extract this hydrogen, hydride ion will extract this hydrogen, and here this having a negative charge, this will attack over here, and this chlorine will get out. So what we will get? We will get here this OH and this O, BN. So I may write it BN, benzyl group. Now, so here we will use only one equivalent of this, so that only one OH is protected. So let's see, let me write it one equivalent of this, and here also one equivalent of this. Okay, so that only one OH get protected. And now this OH, this can be oxidized. So if we oxidize it, we may oxidize it with the help of this DMSO and this triethylamine, and this is a Swan's reaction. So this will get oxidized. This is a secondary alcohol. So as this is a secondary alcohol, that would be converted into ketone, and we may have here benzyl group. Okay, now so here we have to get this OH and this methyl group, and this may be done after the nucleophilic addition of this is in our reagent. Okay, followed by this hydrolysis. So what we may get? So minus plus. So here this CH3 minus, it will act as a nucleophile. And it will add over here. Okay. So suppose if we have a CH3 MgR, so we may write here, we may use this reagent and this one hydrolysis. So what we get here? This would be after hydrolysis, this will be O minus, that would be converted into OH, and here we have one of the methyl group, and now this is the benzyl ether. Now what we can do here? Now, so we have got this portion. Now this OH, now we have to get this ketone over here, so this should also be oxidized. So for that, first of all, we will deprotect it, and after deprotecting, we will oxidize to get the keto group over here. So now let's deprotect it. So deprotection with the help of dehydrogenalysis, that would be done. Dehydrogenalysis, okay, hydrogenalysis, that will be there, and this will get broken, and we will get here and here OH. Now again, that can be oxidized using this Swann's reagent, Swann's reaction, DMSO and this triethylamine, and we will get our desired product. Now we are getting the desired product. Okay, so like this. So this is one of the example. Now suppose here this protection is necessary. First, one of the OH groups that should be protected. So suppose if we do the oxidation, then both group will undergo oxidation. Both group will undergo the both OH will convert into this keto group, and if we react it with non-reagent, then here at both this position we have this OH and methyl group at this position. So that's why first of all we should protect one of the OH group, and then the nucleophilic addition reaction of this Grignard reagent can be done, and further deprotecting it, and after deprotection again it may undergo oxidation to give oxidation to give you here keto group. So this is the example for benzyl ether. Now let's come to the another protecting group, that is tertiary butyl ether. Tertiary butyl ether. So for this, the reagent used is, here I have told you, isobutylene under acidic condition that can be used. Suppose if we have isobutylene in presence of H2SO4, now if we have suppose any ROH group, suppose I am taking one of the example, and if we want to convert okay, suppose if we want to add our acetylide group, and this may be added, we know, suppose if we are using the lithium acetylide, followed by this hydrolysis. So suppose if we want to do this conversion, then how we can convert this into this? So as we know, if this is reacted with this, then here this acetylide, it may act as a nucleophile also, and if we act as a nucleophile, this will attack over here, and this bromine that will be leave out. And this can also act as a base. This can also act as a base, and it will extract this acidic hydrogen. So no doubt, first of all, it will extract this acidic hydrogen, as this acid-base reaction being faster. So this will first remove this acidic hydrogen, and then the reaction will go on over here. So we will not get the desired product. So first of all, we should protect this OH group, and we may protect it with the help of, we may convert it into the tertiary butyl ether. So let's see the conversion. Let's see the conversion. Okay, so if we have so this may act as a base, and it can remove this acidic hydrogen, and this will attack over here, and we may get bromine over here, and we will get here the tertiary butyl. So this is converted into tertiary butyl ether. This OH is converted into tertiary butyl ether. Now we can react it with lithium acetylide. Okay, so finally what we will get? Now we can deprotect it. We can deprotect it under acidic condition. It may be deprotected. So this tertiary butyl group that will leave out, and we will get our desired product. So one of the H plus plate may be removed, and we will get the isobutylene back. Okay, so like this. So this is one of the example where the tertiary butyl ether, the alcohol that can be protected by converting it into the tertiary butyl ether. Okay, so let's see the third one, that is THP. Tetrahydropyrenyl ether. Tetrahydropyrenyl ether, we may usually write PTHP, and we may represent it by so the reagent that we may use is this is your dihydropyran. Suppose in acidic condition, and this anhydrous condition here. Okay, so what we can write? Okay, now suppose we have any alcohol. Now suppose if let's take the one of the example, let's see one of the conversion. So suppose suppose this has to convert it into so first of all this will act as a base and it can abstract the acidic hydrogen, and then it may act as a nucleophile to add substitute over here via this SN2 reaction. So first of all, as this acid base reaction being fast, as I told you, so this OH should be protected. So let's see first the protection using this THP. So let's see the mechanism. So we have okay. So now okay, so either here we can write a THP only. We can write a THP only here. In place of this, we may write the THP also. So here I have protected this. I have protected this OH group. Now this can be reacted. Okay. So here acid via this SN2 reaction, this will attack at the back side, and we have this bromine will leave out, and we will get the this nucleophile will add over here. Okay, and in next step we can deprotect it. So deprotection can be done using acidic condition. We can deprotect it, and okay. So like this. So it may be deprotected in this way. Now, so this is about the THP as a protecting group for alcohol. Now let's see the next protecting group, that is trimethyl or trialkyl silyl ether. Trialkyl silyl ether. Trialkyl silyl ether. Okay, so I told you various trialkyl silyl ether, it may be TMS, TES, and so on. I told you. So let us take the example of this. Suppose if we have trimethyl silyl ether. Suppose if we have trimethyl silyl ether, and one of the example that we may take for conversion. Let's see one of the conversion that we may take one of the conversion. Okay, suppose let's see this conversion. So here if we see, if we react with this Grignard reagent, then what will happen? Here the Grignard reagent that will act as a nucleophile and it will act as a base also. So first of all, this it will compete. So this substrate will compete for this one, and no doubt this H will be abstracted first in comparison to this. So first of all, we should protect this alcohol group. So let's see the mechanism. So let's first protect it by using trialkyl chloride. So if we have a trialkyl chloride, okay, so we have a trimethylsilyl chloride. This is TES, trimethylsilyl chloride, and it may be first of all using triethylamine. This OH group may be extracted out, and then okay, so this is protected. Now we have protect this OH group, and now it may be reacted with Grignard reagent, followed by this hydrolysis. So here we will get OH and CH3, and now we have this tertiary butyl group. Now we can deprotect it. So as I told you, for this is silyl ether, trialkyl silyl ether, the deprotecting agent that we use is TBAF. So TBAF, this is a source of fluoride ion. So anything which act as a source of fluoride ion, that can be act over here, because this fluoride ion, it form a strong bond with this silicon. Fluoride ion form a strong bond with silicon in comparison to the silicon oxygen bond. And silicon fluoride bond is the stronger one. That's why we use any fluorinating agent. So this TBAF, as I told you, the structure of this TBAF, this is okay. So tetrabutyl, we know fluorine, this act as this one, and it will attack over the within this over the silicon, as the silicon having this empty d orbital. So it will attack over here, and this bond will get formed, this bond will get broken. So what we can get? We can get the and this can be hydrogenated, we will get the desired product. Okay, so these are some of the example where this alcohol, this ether act as a protecting group for the alcohol. So in my next part, in say part 2, I will discuss some more ethers which act as a protecting group for alcohol. Thank you.